Hello everyone, I'm Martinus Bagus Wicaksono. In this video, I would like to present my homework entitled 2 push buttons control 2 LEDs using LED Hue. Here, in the process, we will have this kind of system. So, at the initial condition, we have 2 push button 1 and push button 2, and then we have a display counter here, and there's also alarm display and LED 1 and LED 2. If we push the push button 1, it will start the process, so the counting up process will run, and then here it will show the process of counting up from 0 until 20, and then after the process reaches 20, then it will light up the LED 1 and shows the alarm here, and then the process changes to be counting down from 20 until 0. If the process reaches 0, then it will make the alarm off and LED 2 turn on and LED 1 turn off. It will continue the process until it reach 20, and it will give the same condition, LED 1 on, LED 2 off, and then show the alarm. And then one time when we press the push button 2, it will stop the process. So those 2 LED will turn off, and then display counter will set to 0 and alarm also off. So that is the process, and then we can repeat the process by pressing the push button 1. The way we develop the system, first of all, we have to have the flowchart first. So here is the flowchart. First, this is start, and then the next process is initialization. So in the initialization, we set the counter display equal to 0, and then LED 1 turn off, LED 2 turn off, alarm off, and then we set the increment value to be 1. Next process is checking the push button. First, we have to check the push button 1. Is it true or false? Is it true? If no, then the process will continue to check the push button 2. Is it true, push button 2? If no, then the process will continue to check push button 1 again. So it will be looped at this position. And one time we have the condition that push button 1 will be true. If push button 1 true, then process will flow to this direction. Yes direction. Next process is we start the process of increment. Here the process will be set as I equal to I plus increment. We have the value of increment 1, so the first value of I equal to 0, so 0 plus 1 will be 1, and then save the value of I to numeric 2. Next, the value of I will be sent to counter display, so we have the counting up process on the display, and then the system will check whether I greater or equal to 20. If no, then the process will go to this branch. So it will continue to increment the value of I until it reach 20. After I equal to 20, then the process will continue to light up LED1 and then show the alarm. Next, set the increment to be -1 and then do the negative increment or decrement. I equal to I plus increment, which is the value of increment equal to -1. So this is the decrement process. Next, save the value of I to numeric 2 and then the value of I will be sent to counter display. So we have the decrement process. Next, system will check the value of I. Is it less than 1? If the value of I still greater than 1, then it means this condition will be no. So the program or the flowchart flow to this direction and do the next decrement until it reach 0 or less than 1. It means that this condition is yes. If this condition is yes, then the flowchart will flow to this direction. It will make LED1 off, LED2 on, the alarm off, and we set the increment to be 1 again. And the flowchart will flow to this point. So after that, it will check the button of push button 1 and push button 2 again. If push button 1 is still true, then it will repeat the process as follows. One time we will have the condition that push button 2 is true. So if the push button 2 is true, then the flowchart will flow to this direction. It means this condition is yes. If this condition is yes, then it will turn off the LED1, turn off the LED2, set alarm off, and then whatever the value of increment, it will be set to be 1. And next, set the value of numeric 2 equal to 0 and set the counter display equal to 0, and then also set the push button 1 to be false, and it will be end condition, or this is like a initial condition after start here. So this is the flowchart of the system that we have. Next, we can continue to lab view. Okay, for the lab view, first we can put the input, which is push button here, and then put again, because we have 2 push buttons, and then for the display, counter display, we have numeric indicator and also string indicator, because in the alarm we have to show the character. In this numeric here, we have to show the number. Next, we have the output LED1 and LED2. So here we can change the name. This is push button 1, and the other is push button 2. And for numeric here, we can change to be counter display, and for the string here, we can change to be alarm. For the output, this is LED 1, and the other is LED LED 2. Okay, we can put the button. Here we have to create the while loop structure. Can put here while loop structure, and then inside the while loop we have the case structure. This is the first case structure, and here we can put the loop condition control. Then for this case structure will be controlled by push button 1. So we can put push button 1 here to control the first case structure. And then here we can change to be the local variable. Sorry, no. Uncheck the view as icon. Okay, then here we will have the increment operation. So in the first while loop, we have to have shift register, so we can add shift register here, and then inside this case structure we will have the add operation. Add operation, and then from the shift register will be connected to the first input of our add process. And then for the other input of add process or increment process, we will have the increment value here, so we can have the numeric indicator here. This for numeric, we can change to be no, not constant, but control. Yeah, put as other input, and then here we can make or create local variable. Put here in the local variable we can add a constant, and we put the value of the constant is 1. So here we have the numeric value at the initial position is 1. We can hide this numeric value, just right click it, and then from here right click it and then hide control, so we will not have the numeric here. Next, for the counter display, we can also have or create the local variable and put here, so that the result of this adding process will be displayed on the counter display. Okay, and then we will limit the adding process here only until 20. So we have to have a comparison here. Comparison that we use is greater or equal to. So here we will have greater or equal to. So the first input will be connected to this, which is the output of the adding process, and the other input we will put the constant here and then put 20 as the value of our constant. And then for the output of the comparison here will be used to activate another case structure. So it means if the value is 20, then it will activate the case structure here. In this case structure, we will make the system light up the LED one and then show the alarm message and change the process of increment to be decrement. So here we can put the alarm here, create the local variable and then put here, and LED also, this is for LED 1, LED 2, and the increment here. Oh, we have to change this one to be increment. Okay, we can create the local variable here. Okay, here we can put the constant. The constant is alarm, it will show alarm here. And then for LED 1 we can also create constant as well. This is true, and here constant false, and for increment constant we have to have -1, so the process will change to be decrement. Okay, we need also save the value of increment process into a numeric. And into numeric indicator, we can uncheck the QS the QS item. Then we can connect to the output of this increment process. We can hide the indicator, and we can connect this to shift register out there. Here is for the true condition of the first case structure. For the false case structure, we need to have this numeric. We need to have this numeric in the false. So the false condition, and okay, next to shift register here. Okay, so for the false condition, of this, case structure, we will have the decrement process. So there will be another case structure here. Okay, and then for the decrement process will be processed in the true case structure. So here we will have the comparison. So this is for the true condition or the end of the decrement process. We will have local variable of let 1. This is the constant will be false, and then for local variable let 2, local variable let 2, this one the constant will be true. Okay, and we also need to stop or to turn off the alarm. So here we can put the constant off, and then change the process to be increment again. So we need to have you need to have the process is changed to be increment. So we put the increment value here 1, and then to activate this case structure we need the condition. So we have to put here n condition, and n is boolean, yeah. Okay, for the n condition it will read the condition of decrement process. Is it less than 1? The value, is it the value less than 1? So we have the comparison here less than. Then this is the constant. You can put the constant here is 1. There, and then the other input is the output of decrement process. Okay, then the other input of n will be the status of or value of increment. Is it minus or not? If the condition is minus, then we can run this case structure. So here we have another comparison which is equal, and the output will be the input of this and logic, and then the first input here we have constant -1, and the other input will be connected to the increment value. we can create local variable here, increment value, change to read, and then we can connect this to the input of comparison equal. Okay, so this is the process of increment and decrement. You can check it. Check. Oh, we need to put the timer here. Timer with timer, and we can put the constant about 1 second. Okay, run. Wait, let me. Okay, normalize the condition, and then we can put the push button here, so it will count to until 20. After it reach 20, okay, light up the light one, and then sound the alarm, and it will counting down until it reach 0, and turn off the alarm, change the condition of LED 1 and LED 2. Okay, so this is the process. So the rest is about the process of turning off the system using push button 2. Okay, you can make it a little bit smaller so that we will have space. Okay, we can put here the other case structure. So this case structure will be controlled by push button 2. So if this is true, then it will turn off LED 1, then it will also turn off LED 2, and it will set the increment to be 1 again, and for the alarm it will clear the alarm condition, and for the counter display it will set the counter display to be 0. So in the initial condition, the counter display should be set to be 0, and for the numeric here, also set to be 0, and don't forget to turn off the push button 1. Create local variable here and turn off the push button 1. Okay, and then for this initial condition we have to set the before push all button is pressed one by one, so the initial condition of our counter display should be 0, and then for the alarm should be clear, and for the LED one it's also off, LED 2 also off. Okay, this is the end of the process of creating the LED view to control the condition. So we can change or we can run the system. Okay, run the system. At the first condition, the counter display 0, LED 1 off, LED 2 off, and we can press push button to start the system. Okay, 1, 2, and so on. LED 1 turn on, LED 2 still off, and the alarm show the message alarm, and then the process change to be counting down until it reach 0. So it will change the condition of the LED 2 on, LED 1 off, the alarm show the message off, the process change to be a counting up process. Then the process it will repeat until we press the push button 2. Okay, push button 2 will clear this all condition. So we can change the mechanical action of push button 2 to be switched until release. So for the push button 1 it will latch, but for the push button 2, if we press then it will work, and then if we release it will back to the initial condition. It is normally open. Okay, this is the end of the explanation video. So thank you for your kind attention.